In this first video, we're going to build an abstract class. And then in the next video, we're going to build two child classes of that abstract class, which complete the abstract methods that are in that class, enabling the child classes to be concrete, which means as a concrete class, we can instantiate each of those classes as objects. And we're going to see that you cannot do that with an abstract class. So we will go through all of this, and hopefully it'll make a lot more sense when you actually see it. Okay, in this video we're going to begin to talk about abstract classes. And one of the things that I want to bring up with abstract classes is the fact that abstract classes can have constructors. Now, what I've done here, let me expand the constructors, is I have properly chained my constructors because in this abstract class pet, we've only got two fields. I'm keeping this very, very simple as an abstract class. There are times when you are going to want to enforce different constraints on the child classes of an abstract class in such a way that you want to do it in the constructor. So it is absolutely normal to see constructors in an abstract class. Obviously, here is the header, and we have the word abstract added before the word class to pet. So pet is going to be our abstract class, and we will descend some concrete classes from this abstract class as we go. Now, we will never instantiate an abstract class. We can't, because of the abstract methods that occur inside an abstract class. So an abstract class can have fields. These fields are inherited by any of its child classes. And remember, a child class in Java can only have one parent class, but you can keep going up the inheritance tree. So you can have a parent class, a grandparent class, a great-grandparent, and so on. In fact, all classes ultimately derive from object. Okay? So when you see constructors in an abstract class, don't let that freak you out in any way. It's normal. Okay, so I've got them chained so you could see them, and now I'm going to fold them up because we're not really going to be worried about them. Getters and setters. You can certainly have getters and setters for your fields in an abstract class. Okay, and these getters and setters are inherited if you need them. Again, I'm cleaning up and folding here. Okay. Let's make sure I get that right. Let's fold that. Let's delete that space. There we go. And again, I'm just trying to make this a little bit easier to read because I'm getting to, there's only 4 of those, my abstract method section. Okay. In fact, I'm going to tighten this up even more. So you'll notice that in my abstract class pet, I have my constructors, my getters, setters, and then I have my abstract methods. Now these are methods, and if you notice, there's nothing folded here. This is just the signature of the method followed by a semicolon. So I have a public abstract void display pet. So we know that it's a procedure. It's called display pet. It has no input parameters. It is abstract, which means in this abstract class, so what this means, okay, splice here. So in my abstract methods section, I have 2 methods that are abstract methods. The first is a public abstract method void called display pet. That means this is a procedure, and this is the signature line for that method. I am not implementing this method in the abstract class. That will be left to any child class that extends the pet abstract class. The same thing is true with the function that returns a string called return sound. Okay, so return sound is a function that will return a string. It is also abstract, and it is not implemented in this method. Okay, so when I inherit or extend from the pet class, I need to implement these two methods before I can instantiate whatever the child class is. Because this class is abstract, I can never go build one of these. I have to have a child class that implements all of these abstract methods. Then I can implement that child class as an object. Here's another thing to know. Let's say in my child class to pet, I only implement this first one. Well, then I either have to declare that child class abstract itself and have its child implement this one, or I have to go ahead and implement this one. Okay? So no matter what I do, all of the abstract methods of the parent must be implemented before I can be in what is known as a concrete class. Okay? So if I'm building a concrete class, I may have to implement an abstract method that's in a great-great-grandparent if none of the classes prior implemented it, which means they themselves would also be abstract classes. Okay? It sounds complicated, but it's really not that bad. In the next video, we are going to take a look at two of examples of child classes of the pet class. And then we'll see how those are implementing both of these methods. One of them we're going to build from scratch. The other one we're going to go ahead and just look at how it's implemented in a similar manner. So now you've seen how we build an abstract class. In the next video, we're going to build a couple of those child classes so that you can see how we're going to implement those abstract methods in a child class, which will then be considered a concrete class, meaning we can instantiate those two classes as objects, something we cannot do with an abstract class. So I'll see you on the other side.